In this video, I'm going to give an introduction to confidence intervals. I'm going to talk about this using an example, so let's go ahead and read the example first. In a recent survey of 500 likely voters, 48 supported the Republican nominee. All right, so what's going on here? They told us that 48% support the Republican nominee, and they took a survey of 500 likely voters. All right, so what are they trying to do? They're trying to get at who's going to win the election, right? So what they're trying to estimate is the true population proportion of people who support the Republican nominee, right? So what they've given us, though, is a statistic, right? A sample statistic. But what they're trying to get at, what they're trying to tell us is something about the population, right? So actually, let's define some notation here. They have given us p hat. P hat is the sample proportion. Sample proportion. All right, and in this example, p hat equals 0.48. All right, so sample proportions are always numbers between 0 and 1. So you would change that percentage over to a decimal. Okay, what they're trying to tell us is something about the population proportion. Population proportion, all right? Right. So, if we were to think about this, like, so here's like a number line. So, actually, here's 0, here's 1, right? Somewhere on this number line, between 0 and 1, is the population proportion, P. But we don't know where it is, do we? Right? That's why we went out and we got a sample. If we knew where the population proportion is, we wouldn't need to do any sampling. We would have no need for statistics, right? But we have to wait till election day to actually figure out what the population proportion of voters feel about the Republican nominee. So, since we're impatient, we don't want to wait for election day. We take all these polls, and these polls give us sample proportions, right? So they give us estimates. So say, it could be that this estimate could be here, so p hat there. If we got a different estimate, it could be somewhere else. But it's an estimate, and it probably doesn't lie on exactly where p lies. But hopefully it's close. That's the goal. All right. So this p hat, this is called a point estimate. All right, and you can see how I drew it as just a single point. All right, so what is a point estimate? A point estimate is a single value used to approximate a population parameter. So p hat is a single value that is used to approximate p. All right, another example of a point estimate that we're going to talk about later in another video, we'll be talking about x bar. Remember x bar? That's the sample mean, right? So sample mean tries to approximate mu, which is the population mean. Right. So we'll be talking about both these point estimates and confidence intervals for both p hat and x bar. So I just want to mention that is also a point estimate. All right. So what is a confidence interval? How is a point estimate different from a confidence interval? Well, confidence interval, what we do is we create some sort of interval around the point estimate, right? So it's a range of values that are trying to estimate the population proportion, right? So it's a range of values that are trying to estimate a population proportion. So what we do is we first we estimate p hat, right? We estimate the point estimate. Then what we do is we go a certain amount to the right or to the left and a certain amount to the right, and we create some sort of interval. Actually, that amount that we go, is called the margin of error, okay, which is E. So margin of error. Okay, so we calculate p hat. We put up an interval that is p hat minus E and p hat plus E, plus this margin of error. And then that creates an interval for which we hope that the population parameter lies within. right? We can't guarantee that the population parameter lies within. Of course, that these are just estimates from a sample. So there's some level of uncertainty about whether or not the population parameter lies within. Okay, and actually, how confident we are is called our confidence level, right? So our confidence level has to do with how confident we are that this interval contains the true population parameter. Okay, and so actually, so confidence level, so for example, we could set up a confidence level of 95%. That's a really common one, right? So say we set it up as the 95% confidence level. All right, so this means that we're 95% sure the population proportion, in this case we're talking about population proportion, lies within this confidence interval. Right? Now, what does it mean to be 95% confident? It's slightly different than saying that there's 95% probability that the population mean lies within the interval. Okay, so let's talk just briefly about what it means to be 95% confident. Right. So there's a true value of p somewhere on the interval. This is something that we need to understand, that there's somewhere between the interval 0 and 1, there's a true value of p. Right. So we go and we calculate a confidence interval, and that interval either contains p or it does not. So this interval I just drew does not contain p. Right. But it could. Right. So I could do another one. So so this is say this is one sample. So this is the first time I go out and get a sample. And then say I go out and get another sample, right? In reality, people wouldn't do this, but let's just think about this as a thought experiment. So I would go out and get another sample, and this next sample would say it contains the population parameter. Right? And then say I were to do this over and over and over again, getting lots and lots of different samples, right? Completely different samples, where the true population parameter never changes. It's always the same, right? That value for the true population parameter is always the same. It's just the sample proportion that changes, right? Because for different samples, the sample proportion will change. And so therefore, where your confidence interval is will change as well, okay? So your confidence interval can be in slightly different places. And sometimes it will contain the truth and other times it won't, right? So what a confidence level is that says that 95% of the time with repeated sampling, the confidence interval, which is noted with CI, the confidence interval will contain the true population parameter. Okay, so there you have it. That's a very brief introduction to what confidence intervals are. In the next few videos, we'll build up and we'll start talking about how do you calculate this margin of error, right? And then once we know how to calculate that margin of error, we'll be ready to go ahead and start calculating these confidence intervals.